Welcome to our channel Space TV, where we explore the marvels of space and beyond. Today we delve into the extraordinary world of the International Space Station. Floating gracefully at an altitude of about 400 kilometers above Earth, the International Space Station stands as a testament to what humanity can achieve when nations unite for a common purpose. This orbiting laboratory isn't just a technological marvel, it's a vibrant hub of international cooperation and scientific exploration. The ISS serves as a unique platform where astronauts from around the globe conduct groundbreaking research in an environment that Earth-bound labs cannot replicate. Here, in the vastness of space, experiments conducted in microgravity contribute to our understanding of multiple disciplines, including biology, physics, and even human physiology. Moreover, the ISS is a cornerstone of international diplomacy in space, embodying a spirit of global partnership. It shows us that the challenges of space are best met together, rather than in isolation. Join us as we embark on a journey through the incredible story of the ISS, from its conceptual beginnings to its significant impacts on humanity. The dream of a space station has been alive since the mid-20th century. Visionaries from all corners of the globe shared a common aspiration to maintain a permanent human presence in space. This dream was nurtured by the tales of science fiction and bolstered by the rapid advancements in space technology following the initial forays into the cosmos. As the space race unfolded, the idea of a space station evolved from fantasy to tangible goal. It was in this climate of innovation and competition that US President Ronald Reagan in 1984 officially proposed the establishment of a space station. This wasn't just another space project, it was an invitation to the world, a call to unite under a banner of peaceful exploration and scientific discovery. Reagan's proposal was met with enthusiasm and support, transcending national rivalries that had previously defined space exploration. This led to the establishment of the International Space Station program, which would soon see major space agencies, NASA from the United States, Roscosmos from Russia, ESA from Europe, JAXA from Japan, and CSA from Canada, coming together. Each brought their unique capabilities and perspectives, weaving a tapestry of international cooperation and technological prowess. This collaboration was unprecedented. Negotiations and planning sessions abounded as each nation committed to this colossal endeavor. What emerged was not just a plan for a space station, but a blueprint for future international partnerships in space exploration. With a shared vision, these global powers embarked on what would become the largest peacetime construction project in human history. In 1998, a monumental journey began with the launch of Zarya, the first module of the ISS. This initial piece, primarily a storage and propulsion unit, marked the start of what would become a testament to human collaboration and engineering prowess in the vacuum of space. Following Zarya, the Unity module, also known as Node 1, was sent aloft on the Space Shuttle Endeavour. It was during this mission that the first American module was connected with its Russian counterpart, symbolizing a significant step in international space collaboration. This connection was not just structural, but represented the binding of two spacefaring nations in a shared quest. As the years progressed, more modules were added. The Russian service module, known as Zvezda, provided the living quarters necessary to support a long-term human presence in space. Launched atop a Proton rocket, Zvezda added vital life support systems and sleeping quarters to the burgeoning station. Transportation of these modules and countless supplies required a fleet of spacecraft. The Russian Soyuz rockets and the US space shuttles became the workhorses of the ISS construction. Each launch was a meticulously planned operation, involving international teams of engineers, scientists, and astronauts. The complexity of aligning orbits, docking with an ever-expanding structure, and the physical construction in microgravity posed unprecedented challenges. The assembly of the ISS was a ballet of technology and human endurance, where every maneuver had to be choreographed to the minutest detail. The Canadarm2, a robotic arm, became instrumental in the construction process, moving large modules into place and assisting astronauts during spacewalks. By 2011, with the addition of the Leonardo Permanent Multi-Purpose Module, the ISS reached its full operational capacity. This module, carried to space by the Space Shuttle Discovery, marked one of the final pieces of the puzzle, bringing additional storage and research facilities to the station. Through international cooperation and technological innovation, the ISS grew into a fully functional space station. This cosmic outpost, now circling the Earth, serves as a beacon of what humanity can achieve when united by a common vision of exploration and discovery. Imagine living in a place where you float in every moment. Welcome to the daily reality of astronauts aboard the International Space Station, a place where the ordinary becomes extraordinary and every task is an adventure in microgravity. Starting from the moment they wake up, astronauts experience a world unlike any other. With no up or down, they sleep tethered to the walls in specially designed sleeping bags to prevent them from drifting around. This unique sleeping arrangement ensures that they don't float into something that could disrupt their slumber or the delicate instruments aboard the station. Mealtimes are also a departure from the usual. Food is not only packaged to prevent crumbs, which could be hazardous as they float freely and could interfere with equipment, but is also chosen to provide maximum nutrition and variety. Astronauts use magnetic cutlery and specially sealed containers to manage their meals, turning what could be a mundane act on Earth into a carefully choreographed ballet in space. Exercise is crucial in space, as the lack of gravity means that muscle mass and bone density can decrease. Each astronaut spends around 2 hours per day on exercise equipment specially designed for space. Treadmills and stationary bikes are equipped with harnesses to keep them in place, and resistance machines help simulate weightlifting on Earth, ensuring that their bodies remain as fit as possible. But it's not all about maintenance. There's also the aspect of scientific discovery. The ISS serves as a floating laboratory where experiments are conducted that would not be possible on Earth. From studying the behavior of fluids and flames in microgravity, to observing cosmic phenomena and conducting medical research that could revolutionize how diseases are treated on Earth, the work done here is groundbreaking. Each experiment also helps prepare for future long-duration space missions. The daily life of astronauts, though challenging, plays a crucial role in our understanding of life in space. Through their routine, we glean insights not only into the potential for future space exploration, but also into the very fabric of our universe. The ISS has not only expanded our horizons, but has tangibly enriched our lives on Earth. Floating gracefully in the vacuum of space, the International Space Station is more than just a symbol of human achievement in orbit. It's a powerhouse of scientific inquiry and technological innovation. Within the confines of this orbital laboratory, researchers have uncovered new ways to combat disease and have engineered materials that could only be imagined on Earth. One of the most significant contributions of the ISS has been to the field of medicine. For instance, scientists have utilized the unique conditions of microgravity to develop better and faster ways of producing vaccines. This breakthrough has implications that reach far beyond the confines of the station, potentially speeding up vaccine production in times of a global health crisis. Moreover, material science aboard the ISS has taken leaps forward. Experiments in microgravity have led to the development of new alloys and improved processes for manufacturing materials that are now integral to various industries, including aerospace and automotive. These materials are not only stronger but also more durable, which can lead to safer, more efficient products. Beyond the realm of tangible advancements, the ISS stands as a beacon of international peace and cooperation. It shows that nations can set aside their differences and work together to achieve remarkable things. The collaborative spirit of the ISS project serves as a model for global partnership, proving that together humanity can overcome even the most daunting of challenges. The ripple effects of the ISS's contributions can be felt in numerous aspects of our daily lives and global cooperation. As the ISS orbits Earth, questions about its future continue to swirl. As we move further into the 21st century, the International Space Station, a symbol of international cooperation and scientific achievement, faces a horizon brimming with possibilities and challenges. Discussions are actively underway regarding the extension of the ISS's operational life. Originally slated for decommissioning in the late 2020s, there's now a concerted effort to push this date further into the future. This extension would provide more time for scientific research, technology testing, and perhaps most intriguingly, the development of new space habitats. In addition to life extension, potential upgrades to the ISS are on the drawing board. These enhancements are not just about maintaining the station's viability, but are aimed at increasing its capabilities. Proposals include the addition of new modules to facilitate a broader array of scientific experiments and to better accommodate the growing interest from private companies. Speaking of commercial ventures, the role of the private sector in the future of the ISS is becoming ever more significant. Companies are eyeing the ISS as a potential site for space tourism, manufacturing in microgravity conditions, and even as a staging ground for deeper space exploration. These commercial activities could introduce new funding streams and innovation, while challenging the traditional paradigms of space exploration. The legacy of the ISS, however, extends beyond its physical structure and immediate scientific contributions. It serves as a beacon for international collaboration in space, setting a precedent for future projects like the Lunar Gateway and Mars expeditions. The lessons learned from the ISS will inform the design, construction, and operation of these future endeavors, ensuring that the spirit of the ISS lives on in the next frontiers of space exploration. The journey of the ISS is far from over, continuing to inspire and pave the way for future generations. From a vision to a vibrant laboratory, the ISS is a testament to what humanity can achieve together. Born from a dream of a permanent human presence in space, the International Space Station has evolved into a hub of scientific discovery. Here, astronauts transcend terrestrial limits, conducting experiments that benefit both space exploration and life on Earth. As we look toward the future, the ISS continues to symbolize global cooperation and human curiosity. Thank you for joining us on this stellar journey.